The next sessions, I would like to teach you about the negations of propositions. The first thing, together, we read the example. Example 1. Nam and MØNH are disagreeing about bus. Nam says, bus are kind of bus. MØNH disagree and says, bus are not a kind of bus. What do you think about two statements? Which one is true and which one is false? We will examine it later. Coming back to our lessons. The book says to negate propositions, we add or omit the negative words not, to, or from the predicates of the propositions. So, this our example. You see, Nam says, bus are a kind of bus. So a phrase, a kind of bus, is the predicate of this statement. So to negate these propositions, we just add the negative word not to it. We add here, so it's become bus are not a kind of bus. It's so easy. And if we want to negate these propositions, we just omit the negative word not, so it becomes the first propositions, and we have conclusion. The negations of a proposition P is denoted by not P, P with a bar over it. So we can call it not P or a P par. So I'll call not P. We see that not P is true while P is false, and P is true while not P is false. So compared to the example, as you see, bus are kind of bus. Do you think these propositions true or false? It's a false propositions, because bus is not a kind of bus. Bus is a kind of mammals, like dogs, cats, or whales, mammals. So the propositions that Nam says is false, and the negations of these propositions is of course true. So MØNH says a true propositions. To get more understanding, we examine another example. Example 2. A proposition P, 3 is a prime number. So a prime number is predicate. So we just add the negative word not before its predicate, and it becomes a not P propositions. 3 is not a prime number. So which one is true? Do you know what is Brahms number? Brahms number, I'll supply its definition for you. A Brahms number is a natural number greater than 1 that cannot be formed by multiplying two smaller natural numbers. For instance, you know, 5 equal just 2 ways. 5 multiply 1 or equal 1 multiplied by 5. So it cannot come from the multiply of 2 smaller than it. 5 equal 5. So 5 is not a prime number. Similarly, 3 equal 2 ways. 3 multiplied by 1 or 1 is multiple to 3. So 3 is a prime number and P is a true proposition. So not P or the negative P is a false proposition. So the numbers, for example, 6 equal 2 multiple by 3. So 6 comes from the multiple. If 6 is product of two numbers that's smaller than 6, it's a 2 and 3. So 6 is not a prime number. It's called a composite number. For example, A equal 2 multiple A 4, etc. It comes from 2 natural numbers that are smaller than 8. And Q propositions. Q proposition says 7 is not divisible by 5. So if we want to transfer to negations, we just omit the words, the negative words, not, and it becomes 7 is divisible by 5. Similarly, which one is true and which one is false? So it's quite easy. You see, 7 is divisible by 3. Is divisible by 3. By 5. I'm sorry, and by 5. Divisible by 5. It's true or false? It's true or false? Of course, it is false, because 7 cannot be divided by 5. So if Q is a false proposition, so not Q is a true proposition. And exercise for you. Negate the following propositions and determine whether above propositions are and their negations are true or false. The first P propositions. Pi is a rational number. So a rational number is its predicate. So if you want to transfer its into negations, we just add not here before its predicate and after the verb is. So it becomes pi is not a rational number. So pi is true propositions or not pi is true propositions. Firstly we need to know what is rational numbers. So it is definitions for you. A rational number is any numbers that can be expressed as the quotients or fractions p over q of two integers and numerator p and a non-zero denominator q. For example, 2 over 3 is a rational number, right? Because the numerator is 2 and denominator is not non-zero integers, or we can have negative 3 over 5 is a rational number. So pi equal 3.1415 9, etc. There are a lot natural number after the size the dot, so it cannot equal a number that from p over q. So the p is a rational number is a false propositions, and pi is not a rational number, is a true propositions. And the last exercise, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So firstly, we need to transfer these propositions to its negations. We determine its predicates is after the verb is. So we just add not here, and the not q propositions is the sum of the lengths of any two sides of a triangle is not greater than the length of the third side. We need to determine the q propositions or the not q propositions, which one is true and which one is false. Firstly, we need a triangle. Now, it's triangle, right? It's triangle. We had 3 sides. First side 8 is, you can see. The exercise says that the sum of the length of any two sides of a triangle, that means the sum A plus B or A plus C or A plus no B plus C is greater than the length of the side. So that means E greater than the left side. The left side, that means E greater. Okay. E greater C E greater than P and E greater than E greater than A. 3 in equations are true, so the Q propositions is a true propositions and not Q is a false propositions. Now we are about to finish this sentence. Could you understand everything or just something? See again to make sure that you can understand every word and every knowledge that I want to teach you in this lesson.